Rising, yeah, again it is
There's a
rising.
new variant.
Yeah, maybe it's like a third wave. So a little bit worried about the variant. I'm vaccinated fully. Like I'm done with 2 doses. Many teachers have done with 2 doses, or others at least they have got one at least. But still, since the variant is changing, we don't know about the effectiveness of the vaccine. That's the problem. Okay, now I've started recording. We'll move to the chapter amines. So, amines, as the name indicates, they are the derivatives of ammonia. So, what is the formula for ammonia? NH3 is the formula for ammonia. Replace one hydrogen, two hydrogen, or all the three hydrogen atom of ammonia by an R group. This R group can be an alkyl group or it can be an aryl group. So, they are ammonia. So amines have the general formula RNH2. They are derivatives of ammonia. They are prepared by replacing hydrogen of ammonia with alkyl or aryl groups. Now, when you look into the structure of amine, wherever you see nitrogen, then there is lone pair of electrons. So, nitrogen atom of amine is trivalent. It carries a lone pair of electron, and nitrogen orbitals are sp3 hybridized. There are three types of classification under amine. First classification is based on the number of R group. If amine is having one R group, that is one hydrogen of ammonia replaced by one R group, then it is primary amine. Secondary amine, in ammonia, two hydrogen atom is replaced by two R group. It is secondary amine. Then tertiary amine, all the three hydrogen atom is replaced by three R groups. So tertiary amine don't have any hydrogen atom. So this is the first classification. And second classification is based on the type of R group. If R group is aliphatic, like methyl, ethyl, propyl, butyl, then you'll be calling that amine as aliphatic amine. What is aromatic amine? Amine to which an aromatic ring is attached. This is called as aromatic amine. The parent aromatic amine will be aniline because benzene ring attached to NH2 is aniline. Aniline is a primary aromatic amine. How you have under aliphatic amine, primary, secondary, and tertiary. Similarly, under aromatic amine, you have primary aromatic amine, secondary aromatic amine, and tertiary will not be called as aromatic because under aromatic amine classification, you cannot replace all the three hydrogen atom of ammonia by an aromatic ring. Only one R group will be aromatic ring, the remaining two R groups will be aliphatic. So we have seen an first example of primary aromatic amine where one R group is replaced by aromatic ring. Look at the second example. Here one R group is replaced by aromatic ring, another R group is replaced by aliphatic ring. Third example, which is tertiary, one R is replaced by aromatic while two R group is replaced by aliphatic. So you don't have a pure tertiary aromatic amine. Then the third classification is based on the type of R group. Say for example, if my secondary amine is possessing two R groups. So the example is shown in the picture. Here both the R groups are different. Say for example, I can have NH, one side methyl group and another side methyl group. So here both the R groups are same. So I'll be calling the name dimethylamine or diethylamine where both the R groups are same. So that is called as simple amines. If the R groups are different, say for example here, one R group is methyl and another R group is an aromatic ring. So here two R groups are different. This is an example for mixed amine. So we have seen three classification. First one is aliphatic aromatic. Second one is classification based on aliphatic amine like primary, secondary, tertiary. Third one aromatic amines classification to primary aromatic, secondary aromatic and tertiary aromatic. Then you have simple amines and mixed amines. So this is all about aromatic amines. So amino group attached to aromatic ring. This is a parent compound aniline. So to this, other substitution will happen, like two methyl groups attached. So this is an example for tertiary amine, because one R is methyl, another R is methyl, another R is aromatic ring. So the name of this compound is N dimethyl aniline. So this is methyl aniline. Next, moving to the nomenclature. So they have common name as well as the IUPAC name. Common name is alkyl amine. Say for example, methyl amine, ethyl amine, propyl amine, butyl amine, pentyl amine, hexyl amine. That's all. So common name is alkyl amine. That's all. What is the IUPAC name? You will be taking the parent alkane. Replace E of alkane with amine. Say for example, let us work on the IUPAC name of this compound. This is methylamine. Count the hydrocarbon here. There is only one carbon here. So this should be methane. Replace E of methane with amine. So it is methanamine. Now this is ethylamine. IUPAC name will be start with ethane. Ethane's E will be replaced with amine. So it is ethanamine. Okay. And what is this compound? You have two ethyl groups. You have one methyl group. So this is as per the alphabetical order, diethyl methyl amine. And what is this? There are two phenyl group attached to NH. So diphenylamine. So common name is alkyl plus amine, while IUPAC name is the suffix alkanes E replaced by amine. So these are the some examples of common name as well as IUPAC name. How to prepare amines? First one is reduction of nitro compound. So you have to take nitrobenzene. Reduction means addition of hydrogen. So majority of the reduction takes place with platinum, palladium or nickel as a catalyst. So you will be getting aniline. Next reduction is with nitriles. The formula for nitrile is RCN. So add hydrogen, nickel as a catalyst, you will be getting corresponding amines. Next reduction of amides. RCONH2 is the formula for amide. This is reduced in the presence of lithium aluminium hydrate. You will be getting corresponding amines. Fourth method is ammonylysis of alkyl halide. Take alkyl halide, react it with ammonia. Here ammonia acts as a nucleophile. It undergoes lysis. So this is called as ammonylysis. So when alkyl halide reacts with ammonia, you get primary amine, which will be further reacting with alkyl halide to give you secondary amine. Further reaction with alkyl halide tertiary amine. Further reaction give rise to quaternary ammonium salt. Okay. This method has a disadvantage. There will be a mixture of different types of amines. If you want only primary amine, then you should increase the concentration of ammonia. So we have seen four methods of preparation of ammonia. Next, we have two naming reaction called Gabriel thalamide synthesis of amines. So you need to take thalamide, whose formula is benzene, CO, both joined by NH. Alcoholic KOH, potassium thalamide. Treat it with alkyl halide, alkyl thalamide. This will be treated with NaOH. You will be getting primary amine. The main drawback of Gabriel thalamide synthesis is it can produce only primary amine. Primary aliphatic amine, especially primary aliphatic amines can be produced. Aromatic amines cannot be produced by this method because aromatic ring will not undergo, that is haloarenes will not undergo nucleophilic substitution reaction. Why? We have seen the reason under the chapter haloalkenes and haloarenes. Last naming reaction is Hoffman bromamide degradation for amines. So name indicates amide. Bromamide. So I have taken an amide RCONH2 plus bromine is taken NaOH. Why this is called as degradation reaction? Because the amine produced will be one carbon less than that of your corresponding amide. You started with RCONH2, so you ended up with primary amine. So you ended up with primary amine plus sodium carbonate plus sodium bromide plus water. So Hoffman bromamide degradation means preparation of amine from amide and bromine, where the product amine will be one carbon less than that of parent. Okay. Now, what about the properties? Lower members have fishy smell, they are gases. 3 to 5 carbon atoms will be solid. Tertiary amine is not soluble in water. They cannot form hydrogen bonds because they don't have hydrogen bonds. The order of boiling point will be primary, followed by secondary, followed by tertiary. Then, under the chemical reactions, we have the first reaction as basicity. Um, Your amines, alkyl amines are stronger bases than ammonia. Why? Because you have alkyl group. Alkyl group will be electron releasing in nature. Aryl amines are weaker bases than ammonia. Why? Because aromatic group is electron withdrawing in nature. So because of this, aliphatic amines are stronger bases while aromatic amines are weaker bases than ammonia. Since amines are basic, they react with acid to give you salt. So the basic character of amines can be understood by the simple reaction where the Kb value is more, so they are the stronger bases. So here you have an alkyl group. They are electron releasing group. They release electron towards nitrogen. So the shared pair is easily available for sharing with the proton of the acid. So whenever they are going to share a proton, means they are available for a reaction. So they are stronger bases. Why they are stronger bases? Because they are accepting a proton. Then this is aromatic amine. Why they are weaker bases than ammonia? Because you can see the aromatic ring is electron withdrawing in nature. Whenever I say aromatic ring, then double bond is present. Double bond is there, then resonance possibility is there. When resonance is there, then lone pair of electrons are less available for protonation. Also, the anilium ion which is produced can accept a proton. That's why you got anilium. This anilium will be having two resonating structures, so more the stability, so it is less available for reaction, so it is less basic than ammonia. So first chemical reaction is basicity, second reaction is alkylation. All primary, secondary, tertiary amine will react with alkyl halide resulting in ammonium salts. So here you have ethylamine reacting with alkyl halide. So after the subsequent reaction, you will be getting quaternary ammonium salt. Even aromatic amines also undergoes alkylation to give quaternary ammonium salts. So for these, the alkyl halide should be present in excess. Next is acylation. Your primary aromatic, secondary aromatic, primary aliphatic, secondary aliphatic. They all react, except tertiary, they all react with acetyl chloride resulting in ethyl ethanamide plus HCl. Why tertiary is not involved? Because when you see the examples here, the NH of your amine is involved in this nucleophilic substitution. In case of tertiary amine, this NH group will not be there to form a complex. So tertiary amines will not participate in acylation, while primary and secondary amines will react with acetyl chloride. Both aromatic and aliphatic will react with acetyl chloride, resulting in amide complex, ethyl ethanamide or diethyl ethanamide complex. Next, I think I told about the solubility of a complex. Yes, Noma? I was explaining about the solubility of this ethyl ethanamide complex because H is there. This will not be soluble, and here there is no H, so this is soluble in alkali. Yes or no?
Yes, ma'am.
Okay, so that point also try to remember. Next, carbylamine reaction is otherwise called as isocyanide reaction, where your amine, primary amine will be reacting with chloroform and alcoholic KOH to give you isocyanide. So this reaction is otherwise called as isocyanide reaction. So both your aliphatic and aromatic amines will react. Only primary amines will react. So here ethylamine is reacting with chloroform as well as with KOH to give you ethyl isocyanide plus KCl plus water. Second example is aniline with chloroform and KOH give you benzyl isocyanide plus KCl plus water. Then reaction with the nitrous acid. All the three amines will react with the nitrous acid in the presence of NaNO2 plus HCl, resulting in diazonium salts. See here, aniline, which is an aromatic amine, as well as your primary amine, react with nitrous acid in the presence of NaNO2 and HCl to give you benzene or alkyl diazonium chloride. Then Hinsberg reagent. This is a reagent which is used to differentiate different types of amine. Hinsberg reagent will be, the primary and secondary amines will show positive test for Hinsberg reagent, while tertiary amines will not react with the Hinsberg reagent. Whether you remember Lucas test, yesterday I asked one question when I came here. Tertiary alcohols will produce turbidity with Lucas reagent. Primary will not produce immediately. Secondary alcohols will produce turbidity on heating. So this is all about your Lucas test. Then I think you all remember about aldehydes test, like iodoform test. Methyl containing aldehyde will be responding to iodoform test. So you'll be getting an yellow precipitate. Then Felling's test, then Benedict's test, then silver nitrate test, ammonical silver nitrate. All your aldehydes will be giving a positive test, while your ketones will not give any result. Then what else? Just try to recollect the other naming reactions. Williamson's ether synthesis. Anybody is remembering about Williamson's ether synthesis? Nobody is remembering. Okay. Then Huntsdicker's reaction. Then one more is there, no? Down of Huntsdicker. Their halide exchange will happen. Huntsdicker as well as the other reagent, we will be using mercurous chloride. So in those cases, the halogen of alkyl halide will be replaced by another halogen. So that's called as halide exchange. Nobody is remembering anything, right? So unless you correlate the reaction, it will be difficult. Then anybody is remembering about Sandmeyer's reaction and Gutterman's reaction? I got a spark, suddenly I forgot.
Sandmeyers was
Yeah,
from that
louder, louder. Wait, I'm coming to the main page. A little bit louder, Hansika. Tell me.
ma'am, it was from that amines, formation of the hydrocarbon from amines, ma'am.
Formation of hydrocarbon from amina. So you'll be using copper powder as a. I'm not getting only Hansika. I'm able to see, recollect the page, but I'm not getting the points inside.
Ma'am,
Sandmeyers
it
and
was
Gutterman. Here
Woodson.
only, yeah, you can prepare hydrocarbon from amine.
Yeah,
Okay.
yeah, that one, ma'am.
Okay, the catalyst will be different, right? The reaction will be same for both the cases. The catalyst only will be different, right?
Yes, ma'am, it was copper with the halide.
Mm,
Copper with
okay. Okay. Then Clemenson's reduction, Stephen reduction. Anybody is remembering? Friedel-Crafts alkylation, I think you all can remember. Then Wolf-Kishner reaction. That also I forgot.
ma'am, we have
So,
Grignard reagent also.
which one, ma?
Grignard.
Grignard reagent, that I remember. Methyl magnesium halide. Grignard reagent, I remember. That is methyl magnesium. Okay, Lucas. Even in alcohols, we have more.
We
Only,
have Wood's
yes.
reaction also, ma'am.
Yes, ma, yes, ma.
Wood's reaction.
Wood's reaction, Eater reaction, Wood's fatigue reaction. Yes, yeah, that is little bit, it's coming in the memory. Children, this is the last chapter on organic chemistry. Try to recollect all the naming reactions. Write it and, stick it in your wardrobe where you can have access every day. Just go through once. Okay. So we are in Hinsberg reagent. Hinsberg reagent is nothing but benzene sulfonyl chloride. Grignard reagent is nothing but methyl, that is alkyl magnesium halide, that is called as Grignard reagent. So only primary and secondary will react with Hinsberg reagent, while your tertiary will not react because no hydrogen is there. Just look at the example here. You have got what is this amine? This is a primary amine, RNH2. Primary amine is reacting with benzene sulfonyl chloride to give you, what is this? Yesterday I told, what is the name of this compound? Ethyl benzene sulfonamide. Now you have a secondary amine here because two R groups. Secondary amine is reacting with benzene sulfonyl chloride. So what product you got? N-diethyl benzene sulfonamide. Tertiary amines will not react with benzene sulfonyl chloride. So this test can be used to differentiate between tertiary amine from primary and secondary. In a mixture, primary and secondary will be forming an amide complex while tertiary will not react. So in this way, you can differentiate, right? So nitrous acid means your primary amine will be giving rise to diazonium salts. Even your aromatic amine will give you diazonium salts. But here they have given methylamine will be giving ether. I'm remembering one more reaction now. See here. Methylamine give dimethyl ether with nitrous acid. Remember, children, we have read one reaction. I think it's Williamson ether only. Whether I'm coming to the main page back, we have read one reaction where we want the product ether, but we won't be getting ether. Instead, we will be getting alkene. So elimination is more than substitution. Whether you people remember that reaction? I think it's Williamson ether synthesis.
Yes, ma'am, it
You
is.
need to take a sodium alkoxide, then an alkyl halide. So you will be getting ether. This is Williamson ether. But when this is okay only for primary alkyl halides. If you take secondary and tertiary, then instead of ether, you will be getting alkene. Okay, so here elimination proceeds more than the substitution. So I think you can take this example as the same way. Say for example here, our intention is to produce diazonium salts with amines. Okay, but methylamine alone will be giving rise to ether with the nitrous acid. Okay, then one more reaction. Whether you all remember about aldol condensation, how you got aldol? Fast. Aldol. Aldol is nothing but alpha hydroxyaldehyde. How it is produced by the condensation of aldehyde. I think you all remember about acetyl. How you got acetyl. Aldehyde plus alcohol giving rise to hemiacetyl, which in turn reacts to give you acetyl. Similarly, ketones will be giving rise to ketols. What is Cannizzaro reaction? Aldehydes which does not have alpha hydrogen, say for example formaldehyde, will undergo Cannizzaro reaction to give you
Primary alcohol and carboxylic acid.
salts of, yeah, salts, yes, salt of carboxylic acid, alcohol and salts of carboxylic acid. Very good. Okay. So now we have seen chemical properties of amine. The first chemical property is basicity. Second chemical property is acylation, alkylation. Then we have seen carbylamine. Then we have seen nitrous acid. Then we have seen reaction with Hinsberg reagent. Children, can I stop here? It is 10:31. Shall we join back by 10:51?
Yes, ma'am.
Okay. So we need to see from electrophilic substitution reaction. Okay. So we will just log out and then we'll try to join back by 10:51. Okay. Okay,
Yes,
ma.
ma'am.
Bye. Yeah, bye.
Thank you.
Thank you, ma. Bye.